they have not definite heat of fusion. To the next property, we know the crystalline solids are anisotropic. What do we know? Crystalline solids, they are anisotropic, whereas they are isotropic. What it means? What do you mean by anisotropic and isotropic? We will discuss it. Clear? In case of, let us discuss the isotropic and anisotropic property. The first one, isotropic. It means, what means isotropic? As the name indicates, iso, it means similar. If a solid has similar physical property in different directions, then it is said to be isotropic. For example, certain physical properties such as refractive index, electrical conductivity, thermal conductivity, thermal expansion coefficient, if it is same in all the directions, it means on changing the direction of measurement, if it is same everywhere in every direction, then that property is termed as isotropic property. What it means? It means certain physical property such as electrical conductivity, thermal expansion, coefficient, thermal conductivity, refractive index. If these physical properties are seen in all directions, then it is termed as isotropic. Certain physical properties such as electrical conductivity, thermal expansion, thermal conductivity, refractive index is same in all the directions. Is same in all the directions, then the solid is said to be isotropic. Clear? It means if we have a solid and if we measure this physical property in different direction, and if it is same, then it is termed as isotropic property. The next one, isotropic property, it is found in amorphous solid. It is the characteristic of amorphous solid. For example, it is the characteristic of amorphous solid. It means amorphous solids are isotropic in nature. So the next one we'll discuss an isotropic. Anisotropic, what it means? If this physical property is different when we measure from different direction. It means if thermal conductivity, electrical conductivity, refractive index is different in different direction, then that solid is said to be an isotropic. What we got? We got if certain physical property such as electrical and thermal conductivity, electrical thermal conductivity, to the next one, thermal expansion, thermal expansion coefficient, to the next one, refractive index is different in different direction. Then that solid is said to be, that solid is said to be an isotropic. Clear? What we got? In anisotropic solids, the certain physical property such as electrical conductivity, thermal conductivity, refractive index, thermal expansion coefficient, it is different in different direction, then that solid is said to be an isotropic. For example, crystalline solid. For example, crystalline solids are anisotropic in nature. Clear? What we got? Crystalline. Let us understand the isotropic and anisotropic property by taking an example. For example, in case of silver iodide, AgI. In case of silver iodide, it has negative thermal expansion coefficient in one direction, whereas it has positive thermal expansion coefficient in other direction. In case of silver iodide, what we got? It has negative thermal expansion coefficient in one direction, and to the next one, it has positive thermal expansion coefficient in other direction. What we see here, if we have the example silver iodide, it means in one direction on increasing temperature the length increases, whereas in other direction on increasing temperature the length decreases. What we see here, it means the thermal expansion coefficient in one direction is positive, whereas it is negative in another direction. That's why we can say silver iodide is anisotropic in nature. Let us take another example of graphite. What we see here, in case of graphite, we have studied the structure in class 10. What we have studied, it is in hexagonal layers. This is the first layer. To the next one, I am drawing the next layer. What we see here? We see in a definite layer. What we see in a definite layer, a carbon is bonded with another carbon by the means of covalent bond. Whereas this carbon are also held by the carbon of another layer by the means of weak van der Waals forces. What are these? These are weak van der Waals forces. It means it has higher strength if you want to back from this direction. But it is quite easy to back from this direction. Clear? The next property, what we got in this graphite, what we see here? Here it has higher strength and it resists the backing because of stronger covalent bond, whereas it has not such type of strength in this direction because of weak van der Waals forces. Clear? That's why graphite is soft. So the next one, what we see here, in case of graphite, that one carbon is bonded with another carbon. It means one electron is left. That's why it is acting as electrical conductor in a given layer. But it is acting as insulator in this direction and it is acting as conductor in this direction. How? In this way we can understand what is isotropic and anisotropic. I repeat, if the property is same in different direction, that is, we call that substance as having, it is said to be isotropic. If the property changes in different direction, that is said to be anisotropic. The example of isotropics are amorphous solid, whereas the example of anisotropic solids are crystalline solid. Clear? Let us discuss the interconversion of crystalline and amorphous form. What we discussed? Interconversion. Interconversion of crystalline and amorphous form. How they are interconverted? We know the silica, that is SiO2. We know the silica SiO2 crystallizes into quartz, which have a regular SiO4 4- units. It means if SiO4 4- units are arranged in a regular pattern, then it gives quartz, which is crystalline in nature. On melting it and rapid cooling, on melting it and then on rapid cooling, it crystallizes into a glassy material which has an irregular arrangement of SiO4 4- unit. What we see here? The same thing is here. That means quartz, if it has a regular arrangement, then it is said to be crystalline. When it has regular arrangement, if the cooling is slow, then it has regular arrangement, and if the cooling is fast, then it has irregular arrangement, giving amorphous form. What we got? We got silica, that is SiO2. It crystallizes into quartz, that is it has a regular arrangement of SiO4 4 minus unit. Silica, it crystallizes into quartz, that is, it has a regular arrangement of Si4 minus unit. It means it is crystalline in nature. But on melting and rapid cooling, see here what we are doing, rapid cooling. It is converted into a glassy material. Having irregular arrangement of SiO4 4 minus units. That is what we see here. Silica crystallizes into quartz, which is crystalline in nature, which has a regular arrangement of SiO4 4 minus unit. But on melting and rapid cooling, if rapid cooling is there, then it is converted into a glassy material that it has an irregular arrangement of SiO4 4 minus unit. It means it is converted into amorphous form. Amorphous form. What it means? It means on slow cooling, that is annealing, an amorphous can be converted into crystalline form, and on quenching, that is rapid cooling, a crystalline can be converted into amorphous form. What we got here? Crystalline. It is converted into amorphous by quenching, or you can say rapid cooling. That is, amorphous is converted into crystalline form by annealing, or slow. In this way, we know how a crystalline can be converted into amorphous, and amorphous can be converted into crystalline. What is the reason behind this? The reason behind this is that when a liquid is cooled slowly, then the atoms, molecule, or the ions get its time to arrange in a different layer, whereas on quenching it does not get such amount of time. That's why it has an irregular arrangement, giving amorphous solid. Clear? Based on the nature of bonding between the constituent particle, a solid can be categorized into 4 types. Based on the nature of bonding, let us discuss. Based on the nature of bonding, a solid can be categorized into what one? That one. The first one, it is known as molecular solid. The next one, it is ionic. The next one, it is metallic. And the next one, it is covalent or network solid. What we see here, based on the nature of bonding between the constituent particle, A solid can be categorized into 4 types. That is molecular solid, ionic solid, metallic solid and covalent or network solid. We will discuss them one by one. First of all, we will discuss molecular solid, that is further categorized into, first one, it is categorized into non-polar molecular solid, the next one, it is categorized into polar molecular solid, and to the next one, it is categorized into hydrogen bonded molecular solid. Let us discuss them one by one. As the name indicates, non-polar molecular solid. For example, we have Cl2, H2, the next one O2, etc. What we see here, these are molecular solid and they are non-polar. It means they have what they have. They have only and only they have strong covalent bond in a molecule. But this molecule are united together by the means of weak van der Waals forces. It means in this solid, the molecule have weak van der Waals